Hi, Professor. This is Karan, and I'll be doing the second question of homework 3 that's been given. In second question, we have been given that x is a uniform function between -1 and 2. So, as per the properties of uniform function, the density function is given by 1 upon the magnitude of density function in the density function is the uniform function, and this magnitude is given by 1 upon b minus 1 upon b minus a. In this case, 1 upon 2 minus of 1, that's 1 upon 3 between values -1 to -1 to 2, and elsewhere it is 0. So if we sketch a graph of the density function, we get something like this. Now f of x is given by integration of density function from -infinity to x, in this case from -1 to 2 for the for value of f of x, that's 1 by 3, that's a constant. It's given by 1 upon 3 x plus 1, as there would be a delay of there's the delay of 1, so 1 by 3 x plus x plus 1. So we get a ramp function here. There is also there is also property that the function is given by x minus b, sorry, x minus a upon b minus a. So that's again comes to 1 by 3 x into 1 x plus 1 upon 3 into x plus 1. So if we draw a graph, we get y is equal to x plus with advanced by 1. So we get a ramp function from -1 to 2 with magnitude going to 1 by 3. So we get f of x as x. Now fy of y is given by f of x divided by the derivative of y, that derivative of j, that is derivative of y. Now we have y is equal to x square here. So f of x is 1 by 3, the derivative is 2 by 2x, so we get 1 upon 6x. Now x is nothing but root y, but x, since it's a root, it can take two values, either positive or negative. So we have so we take only magnitude of 1 upon 6 mod of root positive root plus 1 upon 6 the mod of negative root, that comes to 1 upon 3 root y. So if we sketch a graph, we get something like this for fy of y. Now for fy now fy of y is given by integration of density function of y from 0 to y. In this case, it is 0 to 4. It would be 0 to, if I'll not by 4, I'll correct this here. It's 0 to 4, as we have as the value of x is between -1 and 2. For values -1 to 1, the value of y will be some 0 to 1, and from 1 to 2 it will be 4. One sec. Yes, right. For -1 to 1, the value of y will be between 0 to 1, and after that it will be from 1 to 4. So we have integration from between 0 to 4. Now for these values, f of y will be the integration of 1 by 3 root y, that comes to 2 by root 3 y. This is for y between 0 and 4. So we have f of y as 2 by 3 into root y for values between 0 to 4, and on plotting graph, we get graph as this, slightly greater than going towards greater than 1 at 4, and rest elsewhere it is 0. Now, the expected value of Ey would be y into the density function of y. So it's from -infinity to infinity. So we have this here. Now, now f of y is 1 upon 3 root y. Now, if we take integration of that, it is 1 upon 3. One sec, let me check if I done something wrong here. Oh yeah, sorry, this is yeah, right. Since it is y upon root y, we have this as root y. So integration of root y is y 3 by 2, y raised to 3 by 2 upon 3 by 2, that's 2 by 3. So if we solve this function ahead, we get value of Ey as 14 by 9. Thank you.